Okay, so here's the problem. We want to find the absolute maximum and minimum value of the function 5x times x plus 6 to the power of 2 over 5 on the interval from -7 to -1. As always, we ask, well, are we guaranteed a maximum and a minimum value? And the answer here is once again yes, right? Our interval is closed and bounded. We go from -7 to -1 included. And the function, well, it is 5 times x, this is a polynomial, times a power of x plus 6. But as 5 is odd, there is no problem here, right? If 5 was replaced by an even number, we can't take an even root of a negative number. So there could be a problem here. But because 5 is odd, there is no problem. So 5x is continuous everywhere. Same for x plus 6 to the 2 over 5. And so the product is continuous everywhere inside our interval. So both conditions, continuity and closed and bounded intervals, are satisfied. So by the extreme value theorem, we are guaranteed that our function will attain a maximum and a minimum value inside the interval. And we know where to look. Both max and min must occur at either an endpoint of the interval or at some critical point inside of the interval. We already have the endpoints. Let's find the critical points of our function inside of our interval. Of course, the critical points are found by using the first derivative. They are values of x where the first derivative is equal to 0 or undefined. So let's differentiate. Well, the function is 5x times x plus 6 to the 2 over 5, so here we can use the product rule. Derivative of the first function, which is 5, times the second function, plus, now we change the rule, the first function, 5x, times the derivative of the second function. Here we use the power rule, so we bring the exponent down, times 2 over 5, x plus 6 to the 2 over 5 minus 1, but 2 minus 5 is -3, so it's -3 over 5, times by the chain rule the derivative of the argument, but the derivative of x plus 6 is 1. And this is our derivative. Again, we want to solve for the values of x that will give us a derivative equal to 0 or undefined. So it'll be easier if we factor and simplify as much as we can. Well, clearly 5 over 5 cancels. And both terms are multiplied by powers of x plus 6. The idea, as always, is we factor the smallest power. -3 over 5 is less than 2 over 5. This is the only common term, and so we factor x plus 6 to the -3 over 5. Okay, well, here the 5 stays there. And if we remove from here a -3 over 5, we have to bring it back. So plus 3 over 5, but 2 over 5 plus 3 over 5 is 5 over 5, which is 1. So we're left with x plus 6 to the 1, which is x plus 6. If you want to double check, we'll multiply these two terms together. The exponent here is 1, which is 5 over 5, minus 3 over 5 is 2 over 5. Check. We took here all of x plus 6 to the -3/5, and so we're left with simply 2x. Well, we can simplify one step further. We can multiply here by 5 and regroup the similar multiples of x. We'll have 5x plus 2x, 7x, plus a constant term of 5 times 6, which is obviously 30. And now, it's easier when we deal with powers, when the powers are positive, and so we'll send this to the denominator, and the power of -3/5 will become positive 3/5. Okay, now we have our derivative fully simplified. Let's look for our critical points. Here we'll find that there are two types of critical points. Points where the derivative is 0, and also points where the derivative is undefined. So first, f prime is equal to 0, if and only if Well, a fraction can only be 0 if the numerator is 0. So if 7x plus 30 is equal to 0, subtract 30 on both sides. If 7x equals negative 30, divide by 7 if x is negative 30 over 7. This is our first critical point. But because we have a fraction, we could have a division by 0, which would give us that the derivative is undefined, also giving a critical point. Well, again, as we've just said, the derivative is undefined if we have a division by 0. But a number to a given power is 0 if the number itself is 0. So if x plus 6 is 0, and of course x plus 6 is 0, quite simply if x is negative 6. And so we have our two critical points. X being negative 30 over 7 is a critical point because the derivative at this point is 0. X equals negative 6 is a critical point because the derivative there is undefined. And now we can construct our table of values. We have our two endpoints, our two critical points, and notice that both critical points are inside the interval. It is possible sometimes that you have critical points outside of the interval, and then you would simply reject those points. Negative 30 over 7, if you compute this, this is approximately negative 4.29, which is inside of our interval. Alright, so let's now make our table of values. We have our x values, and the values of our function, the y values. Let's start again from the left. So the left-hand point is negative 7. The next value would be negative 6. Our critical point with the derivative is undefined. Our next point is the other critical point, negative 30 over 7. And finally, the last point is the right-hand point of our interval, negative 1. All that remains now is to go back to the original function and plug in for x each value of interest. So evaluate f of negative 7, f of negative 6, f of negative 30 over 7, f of negative 1. Now f of negative 7, you can do this by hand, you'll find negative 35. F of negative 6 by hand again is obvious, you'll find 0. And for these two values, you should use your calculator. F of negative 30 over 7, you'll find, is approximately negative 26.58. And f of negative 1, you will find is approximately negative 9.52. And now we can write our conclusion. What is our absolute maximum? And the corresponding maximum value. Well, let's see. The largest value of y is 0, as the other three values are negative. So this is our maximum value, y equals 0. And the absolute maximum, again, is the x value where the value occurs, and the x value is negative 6. So x equals negative 6 is our absolute maximum, and the maximum value of y attained there is 0. What about our absolute minimum? And of course the corresponding minimum value. Well, the smallest value is negative 35. So this is our minimum value for the function. And where this minimum value of y is occurred is taking place, we'll get our absolute minimum, which is the x value, negative 7. And we're done. Now, one thing that's worth mentioning here is that it is really important that you don't forget that when you look for critical points, it is not simply points where the derivative is 0, but also points where the derivative is undefined. As we can see here, the function attains its maximum value of 0 at the critical point x equals negative 6, which was a critical point where the function, the derivative, was undefined. So those are equally important as points where the derivative is 0. And we saw that for the absolute minimum, it occurred at the left-hand point of our interval. So don't ever forget your endpoints and also the critical points where the derivative is undefined. And that's it.